basically, just looking back at the journey, I myself started as a freelancer, and looking at where we started, I can say Malop and Quora Build, they provided that environment for me. At least I was able to get some spaces to work myself, and then the talents that we hire at Alveum, most of them are product of Quora Build and Malop as a whole. So I am just taking this moment to really appreciate them, and also encourage you guys to also be part of their event, and this ecosystem continue to contribute and may it continue to grow as well. All right, so to myself now, I am a tech operations strategist with engineering, marketing, and software operations experience. Myself, I operate in between the three different aspects of engineering management, which is the people, operations, and technology. Yes, if you look at Avium, we are a software development company, but I like to say, as I say to our people ops team, we're a people company. It's people first, the processes follow, and the technology, which appears to be like the most important thing, that is mostly what is the last thing on the table. And we try as much as possible to bring these three things together to make sure we serve our clients properly. And over the last few years, I've also been lucky enough to work with AI, which is an emerging technology and the technology that everyone is using today. And moving from that, being a content writer, technical content writer, writing a lot of articles about these technologies has given me a lot of insights. And also building with engineers that are working on this AI first product as well has given me enough insight. And working in this industry together, I've seen some kind of things that we work with, and I would just like to share insights on those things, right? So that is basically what this session is going to be about. What I hope that you guys achieve in this session is whatever it is that you're currently building, so far it has AI in it, I hope whatever insight I'm able to share will help you guys to really understand and make decisions that will better the product itself and also help you to scale appropriately. So let's get into it. So I would like to start with this analogy, right? There's a saying that when the only tool you have is a hammer, every problem starts to look like a nail. So you tend to use that hammer for everything, inclusive of things that really don't require you to use them for. For example, we have nails, we have screwdrivers. We have nails, we have screws. If you have a screw that you want to drill into a wood, for instance, you would most likely want to use a screwdriver. But if you really use a hammer for that purpose, it may work. You may get the screw to get into the wood. It may split, it may just go in directly. But when you really look at it, that is when you realize that this thing you've done really would not work, as if you had used a screwdriver to drive the screw inside. And I think that analogy captures perfectly exactly how we use AI or LLMs today. And we'll really go in depth into all this to really understand the difference when you say AI and when you say LLMs. These are not synonyms. They are quite very different things. And yeah, I'm hoping this session would put a lot of insights into that. So the first thing we need to know that general purpose AI, such as ChatGPT and all the large language models we have today, it doesn't necessarily mean it is production grade AI. These are completely different things. Now, LLMs, which are known as large language models, such as ChatGPT, Gemini, etc., they are very good when it comes to language, when it comes to speaking, when it comes to text. But when it goes to other things, other areas like perception, like decision making, they are not so good. Although it may appear so, just using my nail and hammer analogy, it may appear so, but that is not the case, which we would see why shortly. And if we really want to understand this, we need to go back, take a step back, and really understand and explore what AI really is. And if you're going there, I would like to use this image, right? So in artificial intelligence, generally, we have different subclasses and different types of AI, right? Under artificial intelligence, we have machine learning, which are basically statistical models that are used to, train data whenever you have a specific data or whenever you have a problem regarding numbers, regarding different types of problem generally. Use machine learning, which are basically statistical models, when we talk about regression and all those kind of words that you hear in statistics. All these formula and equations, they've been programmed in a way that you can just feed your data into it, and then that data, it goes over it over and over and over again to actually learn and gives you a response so that whenever you now provide it with data that you really don't know much about it, it is going to use that knowledge that it has learned before to now give you an answer. That is basically what machine learning is. And artificial intelligence in general are just systems that try to mimic human intelligence. We can't really say they are very intelligent, but they try to mimic that ability of humans to, learn through repetition, do things over and over and over again, and then get smarter while going over and over, so that when we will now give you a new problem, you'll be able to use that knowledge to answer that particular question you have. Just think of a baby. When you give birth to a baby and the baby is like 2 years, they may not know how to speak, they may not know how to walk, but as soon as they get to do these things over and over and over again, they just learn and get better at it. Same with every skill in the world. If you're a developer, for all the developers that we have here, you can say the really good ones, they've spent a lot of time on it. They didn't give up. After 6 months, after 1 year, they didn't. They just kept going over and over again. And this their experience, this their training, or this their learning has helped them so that when you give them a problem today, they can use whatever they have learned over the years to get a solution to the problem that they are facing at the moment. And that is basically what AI does as well. So as I was saying, artificial intelligence has different types. And as you can see, we have machine learning, we have neural network, which is based on the human anatomy, the human brain, just a very simplistic modeling of the way the human brain works. Those are neural networks. And as you can see, we have different types of neural networks. We have different types of machine learning algorithms. We have different types of deep learning. And this is where it really gets interesting. Because one of the forms of deep learning, as you can see here, is transformers. And it is in this type of transformers, that is where we now have generative AI and tools like LLMs and Gemini and all these other tools that we use. So when you really look at it, you now understand that LLMs, they are not really AI. We have different types of AI, and LLM are just one of the subsets of AI. So when you now look at this and really, really understand this, then you know that there are different ways that you can use AI in your product. It doesn't really have to be by LLMs or whatever. For example, if you want to make a decision on if your product tries to solve a problem of, is it going to rain tomorrow? You can definitely plug in AI into that, your LLM into that, and just prompt it based on what happened in the news over the last 1 week. Is it going to rain tomorrow? And it definitely will give you an answer. Well, is that answer correct? You definitely know it may not be. And why is this so? We'll get to that shortly. But if you understand this, then you can understand the problem you are facing and how you can work on your product to solve it. So, again, this is another breakdown of how different AI have been used in different tools all over in times past. Now, before we had LLMs a few years ago, there are a lot of other solutions that have been using AI. Classical AI, they filter spam and not spam in your email. So when you get an email and it gets classified as spam, and sometimes some just comes directly into your inbox, there's an AI or machine learning model in that workflow, and definitely it is not LLMs. In neural networks, when you want to check handwriting, does this handwriting match the handwriting of the person that has been withdrawing from this account? This was before LLMs. All these things, they are powered by artificial intelligence. Google Translate before LLMs. AI, another type of AI that is not transformer or that is not LLM. And we have all these kind of solutions. But again, interestingly, transformers, as you can see, they power modern language models like ChatGPT for writing, reasoning, and translation. There's no decision making here. We also have diffusion models. These are the ones that power the image generation tools. They are different from transformers again. And we also have multimodal models. These are the kind of models that they work with different forms of input. Text, video, images, you name it. They do all these things. So whatever problem it is that you're trying to solve, you need to take a step back, look at the right AI that helps you to solve that problem. So now, let's talk about how machine learning models, or AI in general, how they actually learn. So that, again, I just want to drive this point home as to why LLMs can never solve all your problems. Yes, if you have language-related problems, like you want to summarize, you want to write an article, you want to do all that, yes, it does that. And we would understand the reason just from this slide. You really don't need to bother yourself about the technicalities at this stage for you to just understand how it works. When you get to the implementation stage, you can knock yourself out and go on the Python courses and do all that. But just try to understand this. So like I said, AI models, They learn through exposure and repetition, just like humans. Just repeat it, pass your data, get a very good data. For example, if you want to learn numbers, if you want to teach a kid numbers, you're going to write the numbers system from maybe 1 to 100, and then have the kid go over it and try to learn, try to write it out over and over and over again. Same thing. You don't go and look at physics textbook and give it to the kid, like, look for the numbers here and try to learn. No, you give it the right data, which is the number, and then from there it learns. So basically the same with AI. Whatever problem it is you're trying to solve, you need to get the kind of data that is related to that problem. If you want to solve a weather problem, you want to be able to forecast the weather, you go back in time, look at the kind of weather that has been in that location for the past 10, 50 years. Gather it, train your AI on it, and then it's going to be able to predict and say, oh, this is December, it's normally very cold around this time. So definitely the weather will be around this area, around this time. If you want to forecast how people travel, you look at maybe December, or look at times when we have festivities, and you say, okay, the model, as it's learning through the data, is going to see the anomalies and the pattern, and say, okay, during this period, people normally travel more. So when you want to forecast for next year, use that information that it has already learned to give you the response for what you're now asking, which is, how is December going to be this year? How is December going to be next year? So that's data, just learning over and over and over again. So the better the data that you can provide your AI systems with, the better the intelligence, that the better it is going to be intelligent. Now, let's look at LLM specifically. How are they trained? If we say they are not that smart, they can't do this and that, we need to understand how they are trained. And for LLM specifically, like I mentioned, it's just data. And the data that LLMs were used to train AI was just text corpus, like a large body of text. The entire internet, I would say. They scraped this data of the entire internet and trained it with it. So basically, all he understands is text and the pattern between the texts. So for example, if you ask an AI, what color is the sky? It's going to tell you blue. Because what it has read on the internet, what it has gone over and over on the internet, there are a lot of people on the internet that has already ascertained to the fact that the sky is blue. So it has been trained over that. So when you ask it and it gives you that response, it is not because it is correct. It is just because it has learned from that repetition of learning over and over again. So next time when you ask it about what does a learning innovation hub looks like, it hasn't seen it before. But it's definitely going to give you a response of how other hubs look like. It's going to form that response and give it to you. And the bad thing about these LLMs is that it will never tell you it doesn't know until you prompt it. So it is very easy for it to hallucinate. Whatever it is you ask it always has an answer. And that is one of the hallmarks of a very bad tutor, or whatever it is you take it as. It's always going to give you something. But how will you now know that that thing is not correct? You would never know until you verify it yourself. So that is why you don't really need to go with LLMs, because when you say you are building a production grade system and you go with LLMs, they are basically going to give you something. They are going to give your investors something. They are going to give your stakeholders something. But is it giving you the right thing? You can never say. So basically, how LLMs evolved from training or on long sentences, everything I've basically explained is contained in this slide, which I would be sharing after this presentation. You can also go over it. Like I said, this is to give you the insights that you need for AI and for to just understand how this thing would power your solutions or whatever it is, the problem you're trying to solve in your product. So, and these are some instances where LLM fails. For example, if you're trying to use it for fraud detection, it is not usable. If you're trying to use it for forecasting, like I said, it is wrong. Decision support, very dangerous, and all these other parts, it is going to fail here, definitely. So these are some systems that they do not use AI at all. So these tools, they've been operating before we had AI, and they definitely do not use LLMs in their solution. So when you're trying to power that solution, look at your problem and look at which kind of AI can give you the solution that you're looking for, basically. So, this is just basically what I said about production-grade AI, and my time is up. I guess my praises didn't work, so I didn't get the 5 minutes extra. But just give me a minute. Let me round up this particular session. So modern products need agents. They don't just need AI, because when you think about it, a production-grade AI cannot work on one model. One model will be able to forecast for you, but will it be able to set the guardrails necessary to make sure that your AI system doesn't go out of bound? Does it make sure that your AI system is safe for users? So you need multiple AIs to make sure that this kind of solution you are building meets production criteria. And this is when we now talk about agentic AI, which is basically different types of AI, bringing them together to form a solution but across different domains. Now, as your responsibility as a builder is for you to really choose the right architecture that will solve the problem, train with the right data. Like I said, data is everything in AI. Train with the right data. You build multimodal systems that are agentic and they are able to solve reasoning problems. They are able to think and take decisions based on whatever results another model has given them. And yeah, the last, I would like to close by just giving you an insight into how we should think about innovation. Because when we really go back and think about it, right, all the questions that has changed, that has shaped humanity, they are basically, but why does this happen? Those common sense things that you see and think, yeah, it's common sense. This is how it should work. Those are the things you really should question. And we really need to start asking the other questions because those that came before us, they will have the liberty of asking kind of easier questions, such as why did this apple fall straight? Why didn't it fall sideways? Those are quite simple questions. But when you really think about it these days, you get to ask questions such as quantum computing, superconductors, and all these very scary words. So we need to really go into these technologies, ask the right questions, and we are able to provide the right solutions to these problems. And it is from there that we can say, yes, we are innovating and we are really building things that will shape the world and shape the tech community at large. So thank you very much for
Thank
giving me
you
this
so
audience, and
much.
yeah, delighted to be here.